Let's break down the basics of a mechanical seal, the pump world's unsung hero. These small but mighty devices are found in countless machines, quietly doing their job to keep everything running smoothly. Without them, pumps and other rotating equipment would constantly leak, causing messes, safety hazards, and expensive downtime. So, what exactly makes a mechanical seal so special? Its job? Stop fluid from leaking out where the spinning shaft exits the pump. It forms a barrier that keeps liquids, gases, or even slurries safely inside, no matter how fast the shaft is spinning or how much pressure is inside the pump. Unlike old-school packing, mechanical seals use two ultra-flat faces, one stationary, one rotating, pressed together with just the right force. This clever design reduces friction and wear, making the seal last much longer and perform more reliably than traditional methods. These faces, made from materials like carbon and silicon carbide, ride on a microscopic film of the very fluid they're sealing. This thin film acts as both a lubricant and a barrier, preventing direct contact and minimizing heat, which is crucial for the seal's longevity. Secondary seals, like O-rings and springs, keep everything tight and flexible. O-rings prevent leaks around the seal faces, while springs ensure the right amount of pressure is always applied, even as parts wear or conditions change. Precision is key. Even a tiny scratch or speck of dirt can ruin the seal. That's why cleanliness and careful handling are absolutely critical during installation and maintenance. Mastering these components is your first step to becoming a seal detective. Understanding how each part works together helps you spot problems early, prevent failures, and keep your equipment running at its best. You install a brand new seal, fire up the pump, and almost immediately, drip, drip, drip. It's one of the most frustrating sights for any technician or plant operator. After all that careful work, seeing a leak right away can feel like a setback, making you question what went wrong. But a leak isn't just a minor nuisance. It can quickly escalate into a much bigger problem. Leaks can mean lost product, create slippery floors and safety hazards, or even force costly shutdowns that halt production and impact your bottom line. Still, don't be too quick to blame the seal itself. More often than not, the seal is just the messenger, alerting you to deeper issues within the system. Leaks are valuable clues, pointing toward possible installation errors, operational mistakes, or underlying pump problems that need attention. Simply replacing seals over and over without investigating the real cause leads to a cycle of endless failures and mounting frustration. That's why troubleshooting is absolutely key. Observe carefully, deduce what's happening, and thoroughly investigate every possibility. Examine the leak itself, inspect the failed parts, and pay close attention to the pump's operating conditions and history. Every drip tells a story. If you listen closely, you can solve the mystery and prevent future failures. Let's meet the usual suspects behind seal leaks. Number 1. Improper installation. Even a speck of dirt or a scratched face can cause leaks. Misalignment is next. If the shaft wobbles, the seal faces can't stay tight. Using the wrong seal for the fluid or temperature is a recipe for disaster. Operational issues, like running the pump dry or excessive vibration, can destroy seals in seconds. The right materials, perfect alignment, and careful installation are non-negotiable. Always match the seal to the application. The seal's fate is tied to the system it lives in. Time to play detective. Here's how to bust a seal leak case. Think of yourself as a mythbuster, ready to uncover the hidden truth behind every leak and failure. Every detail matters, and every clue brings you closer to the real cause. First, always shut down and isolate the pump safely. Lock out and tag out the equipment to make sure there's no accidental startup. Safety is your top priority before you even touch the machinery. Next, carefully remove the mechanical seal. Lay out all the parts in the exact order you took them out. Think of this as preserving your evidence at a crime scene. This helps you spot what's out of place or damaged. Inspect the seal faces closely. Look for scratches, cracks, chips, or uneven wear. These marks tell the story of what went wrong. Compare them to a new seal if you can, to spot subtle differences. Don't forget to check the pump shaft for runout, burrs, or corrosion. Use precision tools to measure. Also, verify the alignment between the pump and motor. Misalignment is a common culprit for seal failures. Double-check that you use the correct seal for the application. Cross-reference part numbers and make sure all seal materials are compatible with the process fluid and operating conditions. When you restart the pump, monitor it closely. Watch for unusual vibration, listen for odd noises, and use an infrared camera to check for hot bearings or pressure spikes. Early signs can prevent bigger problems. Don't overlook the flush lines and lubrication system. Blocked flush lines or poor lubrication can cause seals to fail quickly, so make sure everything is flowing and lubricated as it should be. Finally, remember that sometimes the real issue isn't the seal at all. Problems elsewhere in the system, like faulty piping, valves, or process upsets, can lead to repeated seal failures. Always look at the bigger picture to solve the mystery for good. The best fix is prevention. Here's how to keep seals leak-free. Cleanliness is critical. Spotless parts and hands. No fingerprints on seal faces. Use the right lubricant on O-rings, but never on the seal faces. Always fill and vent the pump before starting. Never run a seal dry. Use precision tools for alignment and tighten bolts evenly. Monitor the whole system. Vibration, noise, temperature, and bearing health all matter. A healthy pump system means a healthy seal. Think like a system engineer. Everything's connected.